The next section we're moving on to is problems involving compound and double angle formula on slide 12. It's going to be example 1. I'll just read the question to you. It says, in triangle ABC, angle D or point D is the midpoint of BC. We have that BD equals DA equals DC, and all of these are D. It goes on to say that ABD is the angle theta, and what we need to do is we need to show that AC, this side over here, is equal to 2D sine theta. So the first thing I'm going to do is I'm going to work in this triangle over here and try and get this information into this triangle here so we can find AC. So we need to get theta in this triangle somehow. So what I can see now is, because this side is equal to this side, we have angles opposite equal sides must be equal. So we know the first thing is angle A1 must be equal to theta. And our reason for that is angles opposite equal sides. So now I know that this is theta. What we've got now, if that's theta and that's theta, I can work out this angle D2. Angle D2 is an exterior angle for this triangle ABC. So that means that angle D2 would be equal to the sum of the interior opposite angles. So we have theta plus theta gives us 2 theta. And our reason for that is exterior angle of triangle. So this is now 2 theta. What we need to do now is I just need to find out these two angles over here, A2 and angle C. Again, we are working in an isosceles triangle, so we know that A2 will be equal to angle C, angles opposite equal sides. I know what this angle is, it's 2 theta. So what we can do here is we can say that A2 plus C plus 2 theta must be equal to 180 degrees. My reason, angles in a triangle. I know that angle C is equal to A2. So we have A2 plus 2 theta equals 180. So here we get 2 angle A2 is equal to 180 minus 2 theta, divide through by the 2, and we get A2 is equal to 90 minus theta. That means now that angle there is 90 minus theta, and this angle here is 90 minus theta. We also know that that is D, and that one is also D. If I had to redraw this triangle for you, so you can see what's going on here. We know that's D. We know that's D. This is 2 theta. This is 90 minus theta. This is 90 minus theta. And we want to work out what this side is over here. So, as you can see, we have an angle. We don't know what the opposite side is. We have an angle opposite side, angle opposite side. So we can use the sine rule. Now it's really up to you how you want to do this. We can use that as our pair or that one as our pair. I'm just going to go for this A over there. So I know that AC over sine 2 theta must be equal to DC over sine 90 minus theta. I'm just going to fill in my missing things here and get the AC on its own. So we'll get AC is equal to DC is D. 90 minus is in the first quadrant, but because we've got 90, we have to use cocoa. So your sign will change to cos, multiplied by sine 2 theta. I'm just going to continue up here. So now we know that AC will be equal to D cos theta multiplied by, and what I'm going to do is I'm going to expand our sine double angle, and this becomes 2 sine theta cos theta. These cos thetas will cancel, and we are left with 2D sine theta, which is what they asked for.